actually the way I do it is I upload to YouTube, and then I give you the link to YouTube. The reason I do that is YouTube will close caption. And YouTube does pretty well for me. It does, every now and then you will see it'll be a little weird, a little wonky in terms of the terminology, but the closed captions are there, which is really, really helpful. All right, what we have passed out are your lovely access codes for Cengage, okay? So you're being direct billed all-inclusive access for Cengage. What that means is you now have access to any Cengage book. So some of you will have noticed that you have 2 numbers on the front of yours. That means I get to see you at 8 o'clock in the morning as well. And it turns out our Intro to Engineering book is also a Cengage book. You will also probably know that if most of you are in calculus or in Calc 2 or in differential equations, depending on where you are in the math sequence, but those books are also Cengage books, which means that if you have Calc and you only have to pay for direct access once, so you need to look and follow your directions to opt out of being billed for like your Calc book and stick with this book, okay? Stick with the one that comes from me. Couple of reasons, well, even on your Calc book it would do the same thing, is that you'll get Physics 1 and Physics 2. It's supposed to continue on. So you should get Physics 1 and Physics 2 and you will for your book. And then any other Cengage book you should have access to. The reason I say stay with mine is because the book we're going to use in here is Katz. The last name of the instructor, or the last name of the author is Katz, K-A-T-Z. It is the same book that they are using at the United States Naval Academy. And it's, I really love her book. I love her to death. She's the nicest person that's teaching engineering physics at the Naval Academy. And so we're utilizing her book as the main book. Most of you guys know we've used Searway here on the Tonkawa and Indiana campuses for a long time. So a lot of my homework, it used to come out of Searway, and because of that, there's a few problems I really, really like, and my assessment was built in Searway. So you also have, as part of your WebAssign, the Searway book as well. You will also have, as part of WebAssign, the OpenStax book. And the OpenStax book is totally free to anybody anyway, so you have that one as well. So those are the 3 books that I'm linking to the class. And in any science, a lot of times, a lot of the stuff doesn't matter which textbook you pick up, okay? It doesn't matter whether you pick up a Searway text or a Katz text, or differences between different physics texts are going to be things like the order in which things are presented. Where do we bring in rotational motion? Where do we bring in Newton's law of gravity? Where do we bring in certain items? So that's one difference between the books. But every now and then there's a different descriptor. They'll talk about rotational motion just a little differently, and depending upon your learning style will depend whether or not you like one book over another. I got to where I was liking how she was presenting in the order of the material that was being presented in Katz, which is why I opted to use that book over the Searway book. And so it's going to be, we're going to kind of work through it. I've been using some examples out of it for a little while, but I just wanted you to be aware of what that is. So you actually will have access to 3 textbooks as part of your WebAssign. So I'm going to bring up Blackboard here so that you guys can kind of follow along on a couple of different things. So when you get into Blackboard, let's go up. And I don't know why they do this in here. I want to go to my left-hand side. Okay, they're going to make me do it this way. My courses come in this way. There we go. All right. Over here on this side, you'll see where the syllabus is, but I also put in the things that you really care about in the syllabus. But I do want to inform you of some differences that I historically have not been doing, but I will do now. Under the policies, there are some new course policies. I can't have a total no cell phone policy in my classes, partially because we will use something called Poll Everywhere, which is a texting poll utility, and I've used it in my other classes. If you've had me for chemistry, you used it there. If you've had me for something else, you've used it as well. That's so I don't have to have a clicker, and you guys don't have to buy a clicker. And it's easy for me to deal with two campuses and do some more interactive stuff with two campuses, which is one of the reasons I like Poll Everywhere. So we will be using Poll Everywhere again, and there's not 40 of you combined, which is good, so I don't have to worry about that this time around. But I also use the cell phone as a tool, particularly in engineering physics. We use it as a tool. So tomorrow, if you have Tuesday lab, or if you have Wednesday lab or Thursday lab, I would strongly recommend that you guys look for a good GPS app, okay? Because what we're going to be doing is doing some surveying type experiments. You also may want to look at an app that does an angle, that you use your phone as a way to measure an angle from a horizontal. I don't care what app you use, but those are apps that we use. So we actually use our phone as a tool. So I can't say no cell phones in class, okay? But I have noticed, and several of us have noticed on campus, that there are times when all you see is the back of the cell phone from somebody, that they're sitting there texting and looking at some people. When I'm doing an ITV class, that can be very, very distracting for the IT people that are trying to listen, particularly on other days, and so that can be a challenge. So we're going to use a 3 strikes you're out policy, okay? I don't mind you picking it up, taking a picture of the screen, and utilizing your phone as a tool-taking device, okay, as a note or helpful and a note-taking device. That I don't mind. But when it's becoming distracting to others, when all you're doing is texting somebody else, things like that, you'll get a warning. Second warning, you'll be asked to leave the class that day and you'll be counted as absent. Third time, I may drop you from the class. Okay? So that's something to be aware of. I am taking attendance. Towards the end of the semester in a couple of my classes last semester, I got down to teaching 2 people. Okay? Part of it is my classes are recorded. So people would opt not to show up if I'm doing my ITV classes, and they would opt not to show up. Well, it's really hard to teach to 1 or 2 people. It's really difficult. So that's why instead of actually going through the role, I will ask you on both campuses to use a sign-in sheet. Even no matter where I'm at, I want a sign-in sheet just so that you guys have had it. So those are the 2 things that are a little different than what I historically have done in my classes. And another thing about cheating is that if you cheat on the final, that will be an automatic F for the class. I allow cheat sheets in here in engineering physics. I have a preference for what I like for you guys to have on your exams, and I'm about to show you where to get that. I would like you to get your FE handbook because it's a tool that you would like to use now, and just like in other things, when you have a reference book that you learn, then you're more likely to use it. And by the time, if you are pursuing a traditional engineering degree, you have to take the fundamentals exam. And if you've been using an FE handbook, you know where things are, you know what kind of information's in there, man, it's a tool that you don't have to figure out how to use 2 months before you're going into the exam. So I will show you how to get your copy of the FE exam. So I allow you to have that FE manual as part of your items for the test. Because I don't make you memorize equations. You will, but I don't make you memorize them. So that's something that's out there. So cheating, I am being pretty persnickety about cheating, okay? I do expect you guys to work as a team, okay? I do expect you guys to have study buddies because that's the only way you're going to make it through these kinds of classes is to have a study buddy. I'm really a facilitator. I'm not really an instructor. You're going to end up learning, and I will see it over and over again. Well, I kind of had to learn it, on my own. I can show you where things are. I can show you how to get the information. I can work example problems. I can do an awful lot of it, but when it comes down to actually learning the material, you guys are going to have to work the problems. You guys are going to be the ones that are going to do it. And so the old adage of see one, do one, teach one really, really, really works. And the only way you can teach one is have study groups. And as most of you guys have experienced, you're in Chem 2 together. You're in Engineering Physics 1 together. You're in Intro to Engineering together. Guess what? You're going to get to know each other pretty darn well by the time the semester's over. And then guess what happens? You go to next semester. You're going to be in Engineering Physics 2 together. You're going to be in thermodynamics together. And then most of you will be in some sort of supervised study together. You're going to get to know each other really, really well before it's all said and done. So that's where the syllabus is, and I just wanted to make you guys aware of a couple of new policies. Here, also, for those of you who have never had me, my grading scale is slightly different. I don't do the typical 90 to 100 is an A. It's a little tough in engineering physics to be getting a 90 to 100. Okay, it's just a little rough. Don't panic, but I will tell you right here up front right now that my average on tests look pretty pathetic. Okay. And there may be a test out there that the average is like a 40. Don't panic, because I use full range. This actually works out to be very well what's known as full range grading. And you guys will have an opportunity to have a 43 on a test. Isn't going to kill you. And you can still make an A in the class with a 43 on a test. Okay. And we'll talk about how to do that here in just a second. So my typical grade scale is 87.5 to 100 is an A, 75 to 87.5 is a B. And I do keep pretty good track of grades so that you guys know exactly where you are pretty well throughout the semester. So that's one of those things that are right there. Oh, let's see.
Are we supposed to be seeing Blackboard?
Yeah, you are. Is it not coming through?
No, we're on you, on the teacher channel.
Well, let me put it in there. Let's see if that goes.
There you go.
There we go. All right. So I'll pop you in a couple more. Definitely holler at me if that happens again.
I will.
All right. So there's the grading scale in Blackboard. There is the presumed, test schedule. But it may be flexible because I try to do tests at certain points in the material. So it just depends on how we're going. So here's why it's doable to still get a good grade in the class and still have a crummy test score. Homework and assignments that are being assigned is going to be 20% of the grade. Quizzes are 20% of the grade. Exams are only 20% of the grade. Laboratories are 20% of the grade, and the final is 20% of the grade. Now, when you get to the final, you will have likely seen just about every question, either in class, on a previous exam, in a quiz, or something very similar to it. So when you ask me for the study guide for the final, I will tell you your quizzes and your prior exams. That's your study guide for the final. And I do an assessment quiz, and that assessment quiz is actually harder than the final, but it will help prep you for the final. Okay? So that's how you get it. And there's extra credit. Okay? Extra credit is built into WebAssign. Your WebAssign has that there's a 10% bonus on your WebAssign for getting your homework done 48 hours in advance. Okay? 10% credit in the WebAssign for getting your homework done 48 hours in advance. There's 2 reasons I do that. 1 is you get a chance for extra credit. 2 is that gets you going to working on your homework before the night before it's due, so you get a chance to have dwell time. So that you get a chance to actually have a chance to ponder the stuff, because there'll be many times that you're sitting there working on a problem, and that in the middle of the night you'll go, I know how to do it now. And if you're trying to do your homework at 1 a.m. before it's due at 9 a.m. in the morning, you don't get a chance for that aha moment. So that's one of the reasons that I do that. So there is extra credit built in. So that way you got those pieces in there. All right. Any questions on my policies, procedures, my grading scale? You guys good over there, Enid? All right. Okay. Next thing about me. Most of you, those of you who've had me in chemistry, know that I go fast. All right? There's two reasons I go fast. One is I just go fast. Okay? That's just me. Now, I'll also warn you that it's 1:30 in the afternoon. Okay, most of you had me in the morning. I am a morning person. 1:30 in the afternoon is going to be entertaining for me. We'll see how this goes. I am not usually, I used to tell my staff when I was working, don't ask me for anything important after 3 o'clock, because I don't do well after 3 o'clock. So just give me a heads up. So I do go fast. That means it's on you guys to go, stop. I got a question. Okay? Or stop, let's go over that again. And if that means you don't want to do it during class, and you say, well, I'll just see about it, and I know it's going to be out on the ITV video, and that's okay, and I can go back through it again and again a couple of times. Also email me, because it's like, I didn't get that, and I'm not understanding that, and I might be able to do a problem on that out there. So just make sure it's on you guys to slow me down. The other reason I go fast is we have got to get through thermodynamics this semester. That means we got to get through all mechanics and thermodynamics. In the old book, that's chapter 12. We got to get through 12 chapters this semester in order to put us in where we need to be to start Physics 2 in the fall. Because we got to get through Physics 2, we got to get through electricity and magnetism, we got to get through simple harmonic and wave motion, and we got to get through optics. Okay? So if you think about all the stuff we've got to do in 32 weeks, I got to move us pretty fast. Because if you guys stay here, I know where you guys end up. But if you move to, if you go to another school and you start picking up, they're going to say, oh, you got that in Physics 1. And if I only got you through Chapter 6, you may not have gotten that in Physics 1, and then you're SOL. You've got to be, so we've got to cover quite a bit of material, and that's one of the reasons that I move fast. So the best thing to do is keep up, okay? Don't get behind, because if you get behind, and in Physics 1, if you get behind, it snowballs. Physics 2, not so bad, because we changed topics in Physics 2. Physics 1, I will tell you right now, it will be a comprehensive exam. Because there is no way possible not to have a comprehensive exam in Physics 1. Because we're going to build on everything as we go. We're going to continue to build. And so that's one of the things that we've got to kind of really work on and keep going. I have lots of office hours, right? And you guys are lucky. We've got 3 people that can tutor as well. So, and you've got another resource sitting right here in the room. That's another good resource. And what's also nice is most of you are in my Intro to Engineering class, and you've got some of those sophomore students who've had me for 3 semesters right there in that class that you're going to get really lucky to be in amongst those students as well. So I think it's going to really be nice to help on that. All right, down here under course material and assignments, I do by week, and I will provide you lots of supplemental information. This is also where I will post links to the videos. I will also post a variety of other videos that are in there that will help you out. You'll usually get something that says supporting videos and supplemental material. I've got a couple in there already. Because this first chapter, we're going to do some odd things. One is doing estimates, and one is doing dimensional analysis. And I will tell you right now, dimensional analysis is going to save your hinds. Dimensional analysis in physics, if you've had me in chemistry, you know I harped on it and harped on it and harped on it. Well, in physics, you thought I harped on it in chemistry. I really harp on it. All right? Because units have both, or numbers have both value and units. Telling me something's 27 doesn't do diddly squat. Okay? The number 27, okay, it might be 27 eggs, but it might be 27 meters per second. It might be 27 light years. 27 light years and 27 meters per second are two different things. Totally two different things. So units are also going to help you figure out whether or not your equations are right. Because most of you are saying, if you just told me what equation to use, I could do it. Well, using your units is going to help you along. So I will post lots of these things as well. I will post a variety of other pieces. You should have a link to WebAssign. The class key is out there. And I will highlight it right now so that you guys know. So if I go in here, let's see. This is my class settings. There's the class key. So for you guys, there's the class key. Northern-Oak 2605 7396. So by Wednesday, I would like to see that you all have gotten into your WebAssign. Because if there's any problems, any issues, sometimes what will happen is you guys can see your calc book, but you can't see the physics book. And so we want to kind of get those problems all worked out as soon as we can. We want to get those problems worked out as soon as we can. You guys got the class key over there? All right. Then, so when we come back here, a couple things about WebAssign. Most of you have seen WebAssign before, so I'm going to go in. We've got the WebAssign for physics. The physics pad or the entry pad is a little different than the math pad. So that's just going in there, getting familiar with the physics pad, how to do some of the exponents and subscripts, how to do a few other things that are in there. So there's definitely some pieces that you'll want to do. That's just in there for you guys. I have it for, I'm not even sure I have it as counting as points. If I do, it's very small. It's like 5 points. I will typically do 2 types of homework problems or homework sets. One, I'll call them pre-work sets, and one will be homework sets. Pre-works are typically worth only about 5 points. It's trying to get you more familiar with the material before you come into class, because physics uses a little bit of different vocabulary, or we use words in a different way than what you're familiar with. So, and things have a little bit different meaning to them. So it's kind of to help you get through there, kind of start looking at the chapter before we get in there. And then I'll do the traditional homework. So there's the first one. I have this due the 17th at 5 p.m. I believe that is, let's see, that's not Saturday. Saturday is the 19th. So that's Wednesday at 5 p.m. Please watch due times. Okay? I don't take late homework. Unless there's some prior arrangements that have been made, I don't take late homework. I'm pretty persnickety about it. Because we're in the middle of a government shutdown, right? Does that mean that the IRS tax deadline filing has changed? Nope. If you have to pay an estimated income tax by tomorrow, It doesn't matter that the government's shut down or not. That estimated income tax payment is still due tomorrow at midnight. I used to work in environmental compliance, and I can tell you that the EPA is even if it's their fault, you can't turn it in. They go, why did you wait till the last minute? So I am very persnickety, and I don't take late home work. Now, if there are extenuating circumstances, and those extenuating circumstances have been discussed prior to the deadline, that's a different issue. Right? That is a different issue. But that is one thing that those of you who have been in my classes before or even hear about me, I don't take late homework. So that being said, when you get into WebAssign, my first recommendation is print out the assignment so that you have a piece of paper to work on it on terms of paper. Because we all know how persnickety the internet is. It's not just NOC. I mean, it can be, you can lose the internet a variety of different ways. It's not just NOC. Although the Wi-Fi has improved greatly over break. And Wi-Fi, particularly in the science building, has improved greatly over break. So that will help.
So bad in the science building.
Huh?
So bad in the science building.
Well, and you guys over in Enid, I think there's a computer lab in the science building that's open and available for you guys over here in Tonkawa. If there is nobody in the physics lab, you are more than welcome to go in and use those computers to do homework. You are also more than welcome in the physics lab over here in Tonkawa. If you don't have any other place to get a study group together, as long as somebody is not using that lab, go for it. Because that lab is usually pretty open, and even on Monday night I teach General Physics 1 one night a week, and that's Monday nights. If I'm here until 5:30 when I start my class at 5:30. If you're in there, you're allowed to go ahead and sit in there as well. Okay, so just be aware that that's there. All right, so that's where WebAssign is, and we've got the first homework assignment for Chapter 1 is already up and available. So make sure you try to get in there. Make sure that you've got access and get in there as well. And if you have trouble with your WebAssign access or anything like that, holler, and we can get you straight. Questions? Okay. I got 15 minutes, so I'm going to go ahead and get started. So that you guys can start working on your homework. I know, you guys just totally went.
I don't know if I not.
No, you gotta get started. Okay. All right. I need you guys over in Enid to tell me how this is going to work. See if we got it. Because if this is going to work, it's going to save me a whole bunch of paper. Okay, so I'm just going to write a word on here and see how it goes. Well, we can barely see it here, but I got it adjusted, playing with the colors. Okay, in here, I think if I do it with the black paper, I got to turn the lights on. There we go. That didn't work. That did bad. I can't tell. That part's not. There we go. It's just being slow. Okay, now I'm going to turn the lights off and see if it does any better. Now that we got it to respond. Okay, looks like I gotta go that way. Or we can play with it and adjust it a little bit. Okay. You guys see that okay over there? Okay, great. That's why I can clean and erase my board. It's a liquid paper board. All right. So, big question that we all ask is, what is physics? So the first thing is, physicists weren't really scientists weren't considered scientists until the early 1900s. That's not what we got our degrees in. That's not even if you went to the shelf to try and find a physics textbook around 1900, you couldn't find one. They would have textbooks that, and I actually have them in my office. They have textbooks called synthetic philosophy or natural philosophy. We were actually philosophers. And I just recently had a discussion with my son because I asked him, he's going for his PhD. He's going for his PhD in psychology. And I asked him if he's done with his coursework. What classes was he taking this semester? And he says, oh, I think I've got all my classes done. Oh, I went, what? You're just now doing your master's thesis. What do you mean you got all your classes done? So he's just doing research. He says, yeah. And I said, oh, that's right. You're one of those other degrees. Okay? Physicists still, to get a PhD in physics, you still have to have roughly half of your graduate hours in coursework. They still do a lot of different coursework. And part of it is, what are we trying to figure out and what are we dealing with when we deal with physics? And then the other question is, why do we save physics for last? Because if you remember, back in high school, you did earth science, maybe some physical science stuff. Then you went to biology, and then you got chemistry, and then if you were lucky, your school had physics. But usually you got it at the end. And then physics people go, that doesn't make sense. Doesn't make sense because what do we deal with? We're dealing with matter or stuff, right? This is stuff. Okay? Chemistry focuses mostly on the matter stuff part, right? Chemistry focuses mostly on the matter part. And we use energy, so we're going to be looking at energy. And we deal with motion. And we deal with forces. Okay? We do all of those different things. And essentially what physics does is gives you the rules. Okay? Those are the rules. How is matter going to interact with each other? Well, chemistry, we can do a whole lot of things, but it comes down to the rules. What kind of forces? When we start talking about the forces, it's the rules. So we actually are going to be looking at those different pieces. So we can talk about energy, we can talk about forces, we can do a bunch of different things, and physics gives us the rules. The reason we say physics for last is because what's the language of physics? Math. And what we're going to do in Physics 1 is we're going to try and sew up the thing that we have done a horrible job as educators over time, all those things that break. So you've been learning how to do math since you were itty bitty bitty, adding, subtracting, you got to algebra, right? You got to a bunch of different things. And now what we're going to do in physics is we're going to take that math and we're going to try to put physical meaning to it. Because a lot of math came from looking at physics. And there'll be times that we actually will derive where did something come from in calculus. So we'll be actually looking at that part and working on that as we go. So that's one of the things that we're going to deal with. We're going to start with what we call fundamental quantities. And this really refers back to our units. Okay, this refers back to our units. So we have fundamental quantities of mass. Mass, matter, stuff. Okay, fundamental quantities. We're going to use SI units. So our fundamental quantity that we're going to deal with is a good old kilogram. Anybody know what the fundamental quantity for mass is in the standard English system of units?
Meters?
Mass.
Pounds?
Pounds is a force.
Pounds per square inch.
Huh?
Pounds per square inch.
That's a pressure.
Grams?
Grams is an SI. How about you guys over in Enid? Any guesses?
She just said pounds is a pressure.
No, pounds is a force.
I said that.
Pounds per square
Was it
inch.
yes of newtons?
Newtons is a force. Okay. Now, I didn't expect you guys because it's not a fun, we don't think about it that way. It's something called a slug. It's something called a slug.
Yeah, I was gonna know.
That's a fundamental unit. That's the fundamental mass unit. Because we have something that we call derived units, and you guys actually talked about a derived unit, and you guys gave me pounds, and you guys gave me newtons. And if I'm doing the abbreviation, this is LB, or you guys might also see it as the number sign if I'm doing pounds. In a lot of engineering, you'll see it as a number sign. And newtons, we use the big capital N. Okay, so we get the big capital N, and I will play with this so that we don't get quite so bad at glare. But if we go to newtons, and most of us know that it's F is equal to M times acceleration, and we will get to those units, but this is going to be in kilograms, meters per second squared. That is a newton, and that is a derived unit, meaning it's made up of other units, okay? It's a derived unit versus a fundamental unit, and my fundamental unit is we do length is a fundamental unit, and that in my SI is meters. In my English unit, it's feet. Then I have time, and that's nice because it's seconds in both of those. Okay. There is another fundamental unit. We won't play with it very much in Physics 1. In fact, we won't play with it at all. And that's a fundamental unit of charge. And that happens to be Coulomb for both the standard English and the metric system. Coulomb's charge is our fundamental unit. Derived units are going to be made up of the other, and so pounds actually is a slug feet per second squared. So we actually have, and that is a force, right? That's a force. So we're going to use fundamental quantities. We're going to use derived quantities, and this is where looking at, if I'm calculating forces and things like that, looking at my units of my different things will help me know whether or not I'm on the right track. So we actually work with those fundamental forces. So we've already kind of talked about this, and I do this all the time. I'll write a series of numbers up here, and one of the numbers that we talked about here just a second is the number 27. And I told you 27 could be a lot of things. It could be 27 eggs. It could be 27 feet. It could be 27 yards. It could be 27 years. But why would I pick the number 27? Why would I pick the number 27 to talk about? It's my favorite number. I like that. Somebody said it was my favorite number. No, there's a reason why I do it. How about you guys? Over in Eden, why would I pick the number 27? Oh, come on. Somebody take a guess. Okay. The reason I do this is because I'm trying to have you guys develop a frame of reference. You all have a piece of paper in front of you. Draw a 3.5 inch line. Okay, look at your neighbor's paper. Is your line about the same length as your neighbor's line? Okay, everybody raise up your left hand. Bend your left hand into a knuckle so that you've got a nice flat spot between your middle knuckle and the top knuckle. On just about everybody in a human being, that is 1 inch. Compare it to your line. So for you guys over in Enid, I'm talking about doing it like that. This right here. And it doesn't usually matter if you're really tall or really short. That's pretty darn close. Okay, so most of you have a frame of reference for 1 inch on your body. That's how we got a standard foot. That's how we got the yard. That's how we got a lot of those in the English system, is that we actually referenced it, and it happened to be the king who was the person who established the unit. But what most of us do, because we don't have a good set of frame of reference, we don't know whether or not our value makes sense. So when we do a calculation, we don't necessarily have a value that makes sense. Most of us, if I tell you if we're traveling along the highway, you can give me, because most of you have been driving, most of you can have a pretty good feel whether you're going 10 miles an hour, 50 miles an hour, 60 miles an hour, or 80 miles an hour, right? You got a pretty good feel for that. But if I now tell you that we're traveling at 35 meters per second, and you've actually calculated that value as an answer to a problem, you have no idea, because we don't live in meters per second. Which is why I gave you the number 27. Because 27 meters per second is pretty darn close to 60 miles per hour. So it gives you a way, as we start to deal with kinematics, it's going to give you at least a ballpark to say whether or not that 27 makes sense. If we've got a horse running 27 meters per second for 5 hours, we're probably pretty sure that somebody either just pulled the numbers out of the air just to make the problem simple, or we've calculated something wrong, because a horse is not going to travel 60 miles an hour for 5 hours.
Damn good horse.
It'd be a really darn good horse, right? Really darn good horse. I mean, that horse is going to keel over and die, but it's a really good horse.
Oh, we never said that the horse had to be running.
Oh, it could be on a train. I like that. Yeah, we got some people thinking outside the box here. But that's why I used the number 27. And I think I'm about to lose my connection over in Enid. So we will start again on Wednesday. I will see some of you tomorrow. Oh, by the way, there is no physics lab manual. No, because I didn't get my job done over the winter, so there's no physics lab manual. We will be doing it on a handout basis. All right, I will see you guys in person on Friday, but we will see you via video on Wednesday.
Are we going to
It's on Cengage. It's part of the Cengage. It's part of this. No, you have 14 days to opt out of being charged. There's a way to opt out in your calc class. You can say opt out of this charge, and so you'll need to opt out of that charge in calc because this will give you your calc.
How do we opt out of it? Do we go somewhere?
When you go onto your Cengage, you'll have a flash and it'll say, especially when you put this in, that you've got all inclusive access with this. And if you still have questions, we have like 14 days to get it all straight. Right.
So do we just log on to the Cengage website?
No, you go through WebAssign and come in through WebAssign and put the course in there, and you've already been charged, and it's got your access code
Okay.
and that's why you have it in the card.
So that's the assignment
For Wednesday, and Wednesday, and that first getting into WebAssign. Yeah, the big critical thing is to get into WebAssign.
Second question. You said Pete tutors chemistry and
Engineering and physics.
where is that schedule at?
Well, we don't have the schedule up yet, but he will be teaching in the evenings, and he will start tomorrow. And it's going to be in, it's across from the biology lab. There's a student office upstairs in the science building.
On the north side?
Mm-hmm. It's in the same spot where my office is, but on the north side.
Okay. Alright. And do you know what time he's gonna be tutoring?
He said, I'm getting the schedule right now, and I'll have a better idea probably tomorrow morning, but he'll start I'm sure around 5:30-ish in the evening.
Okay, so I can ask you tomorrow?
Yeah.
Alright, awesome.
Okay. I will do this because I know he is not going to be in this class. You will be charged, but I wanted to make sure you had a copy there. Yeah.
You were talking to people in Enid?
Yeah.
Is there another class in Enid?
Uh-huh. We're ITV.
Because I'm closer to Enid than I am here.
Oh, if you wanted to switch to Enid, then you could.
They didn't tell me anything about that at all.
Okay, yeah. Depending on where you're physically located, I teach ITV, so it's the same class. And if you wanted to switch to the Enid class, I can do that for you right now.
I don't know, I'd have to look on GPS. I live in El Reno, Oklahoma.
You live in El Reno, so you're coming all the way from El Reno?
Yes.
Okay, let's look. Let's see. Let's look because it's going to be the same. It's the same people. Let's see what we got. Google.
You know how the labs and stuff would work.
Well, we have now. The lab, I will warn you, over in the Enid is at 7:30 in the morning. The lab over here is Tuesday, so you and I have no problem which place you go. I have none whatsoever. If you wanted to go, Google Maps. Okay.
I'll be getting a place closer. I'm starting work in Ponca City. So.
Oh, if you're starting to work in Ponca, then you want to come here.
Yeah.
Then if that's the case, you'll want to come here.
Yeah, my life isn't in El Reno. I usually rent an apartment in Stillwater during the semesters.
Yeah, but if you're trying to get a job so what are you trying to? Where are you working?
Dorada Foods.
Okay, you're doing Dorada.
As one of their engineers.
Oh, cool. Cool.
I have no idea what the engineers would do at a food place, but
Lots. Are you in my intro to engineering class?
I probably no.
Okay.
I'm already.
Yeah, because I'm teaching at 8 o'clock on Tuesdays. I'm doing a 1-hour intro to engineering, and we're talking about all the different types of engineering classes and things like that they're doing. And there's a lot of stuff in the food industry now. A lot of stuff.
Their machines, I guess some of them are dangerous, and I'm going to be putting together procedures for lockout, tag out, and start.
Oh, safety guy. Yeah.
But I've got to make two of them. I've got to make one of them that'll stand up if somebody gets hurt and they have to go to court.
Yeah.
And then another one of them for employees to understand
what they're doing. Yeah.
So one of them's got to have real nice legal words to it, and the other one has to have layman's terms to it.
And they have to match, so you don't get in trouble with the courts. Yeah.
Yeah.
Yeah, so,
I've never done it before, so I'm crossing my fingers that I'll do all right at it. And
because the other thing is, just so you know, we do process technology here at NOC. We teach, I teach an introduction to process technology class, and that's an online class this semester, so we can still get you in if you wanted to take that one. And the intro to engineering is, we'll be teaching that both from, we'll teach that one again in the fall, and we're going into a variety of different things, so.
my major's architectural engineering.
Oh, cool. Well, that's cool.
You say cool, but I'll tell you what, I've already got my foot so far in it that I did.
Yeah, and that's one of the things that we're talking about is the differences between the different programs and the different engineering programs and things that are like that.
Well, I'm seeing the light at the end of the tunnel finally, but this physics I've got